Now we're moving to a different technology, devulcanization, and I'd like to ask John Vierzuk to come up and tell us about Tyromer and how they're going to change the world.
Oh, thank you, Iwan. Really appreciate it. Really appreciate it. So first of all, hi, I'm John, and the COO of Tyromer Inc. I want to extend a big thanks to Iwan, David Wilson, the Tire Cologne, everyone for being here today. So I will talk about our technology and material for a circular economy, and also want to touch on a little bit of the industry trends that we see, things that we think are going to be important, and things that will be developing with more urgency here in the years to come. And so really, this has been a story that you guys know already. There's about 1.5 billion scrap tires that will be produced this year. And we really see this as an opportunity. This is a big opportunity and something that's become more important lately. We see this as a local crop that will come with certainty. So inherently, I have to talk a little bit about Tyromer to explain what we're doing. And really, our solution and mission is to enable the use of more recycled rubber in tire and high-value applications. So a process called devulcanization. As a tire is made, it's vulcanized with sulfur, it's added to heat, it creates a very strong, rigid bond. This is why rubber is such a great industrial product. So devulcanization then is basically preferentially breaking those sulfur bonds again, so the rubber can be reused and remixed. And so through this process of devulcanization, we can reduce the consumption of virgin materials, we can reduce carbon footprints, and we can really help reduce overall compound costs, which, as Iwan was saying, very important. No one is going to pay extra for sustainability right now. Now, a little bit more about Tyromer Inc. We're actually not that new. We were founded back in 2009 at the University of Waterloo in Canada. Now, we use a licensing business model so we can implement our solutions globally. Now, I'll admit we're not true manufacturing experts in the sense that we don't have plants already. We've been operating for 30 years. We've got our pilot facility that has been operating for about 6 years now, and we've actually just opened our new facilities in Windsor, Ontario, and in Arnhem in the Netherlands. Now, a really important thing to understand about us is, again, as a small company, we have to have a strategy of open innovation and collaboration. We've seen so many times that working together is really what drives the progress and the urgency. And so this is always our strategy. We want to learn about the industry and make sure that we can fit in and not necessarily be absolutely disruptive. Now, our Tyromer technology inventor is Professor Kostas Georganakis from the University of Waterloo. He is still our CTO. He still leads our R&D team, and he's still part of our operations today. And again, the product that we produce is devulcanized rubber. It's called tire-derived polymer, or TDP. Now, this is a very simple video. This is actually a video I've been using for quite some time now. So you can see crumb rubber dropping into the extruder there. So it's crumb rubber in the size of about 20 mesh dropping into the extruder. Through a process of heat, shear, and pressure, we do the devulcanization. And that's the devulcanized product that comes out. That is the entire manufacturing process. It is very simple. I like that video because of the simplicity of it. So basically, the crumb rubber goes in, and 100% of the crumb rubber comes out as devulcanized material. Now, there's a little bit of loss at startup and shutdown, but the process is meant to run continuously, and so there's very little waste once you go. Again, I think the simplicity of the process is important to understand here. So a little bit more about the product. We really consider it a combination of low cost and high performance. The TDP can be made from a large variety of feedstocks, so truck tires, passenger tires, mining tires, large tires. It can also be made from various scrap rubbers, so not necessarily just tires, although tires has been our main focus. Factory scrap, non-tire rubbers like EPDM can also be devulcanized. And something important to understand about the technology, it does not change the chemical composition of the material. So if you're putting a passenger tire into the extruder, the same chemical composition is going to come out. The only difference is that the sulfur bonds have been preferentially broken. So same thing with the truck tire. If you put a truck tire in, it has, about 40% natural rubber, maybe 22% synthetic rubber or so, and carbon black. The same ratio of chemical composition comes out the other side. Now, with not just with our technology, but with a lot of recycling technologies, a big concern from the tire manufacturers, and a big reason it's been hard to get the material to be used in the past, has been the consistency. And so the consistency is something that is the utmost importance to us and other recycling processes. So in order to show this consistency, we have to look at our feedstock. So if we put the same exact feedstock into the extruder, the same devulcanized product will come out all day, every day. But as soon as you start having variation in the feedstock, it can create some variation in the product. So for us, we really have to focus on the recycling portion of it, the sorting and grinding of tires, and making sure that the feedstock is consistent throughout our process. Now, one way I like to talk about the consistency of the product and the variation, because inevitably there is a little bit of variation in the product. But I like to compare it to a natural rubber crop. So if you have a natural rubber crop, say RSS3, that comes from West Africa, another crop that comes from Southeast Asia, maybe they had a dry season, maybe they had a rainy season, there will be a little bit of variation in that material as well. But again, the tire manufacturers specify this material, they approve it, and the end product is basically the same. And so that's the way that I like to talk about and think about our product, and the variation in the product is it's really minor. There's going to be a little bit of variation, but if you're mixing the product in, at 20%, it doesn't really have a big effect on the final properties. Now, this is our original pilot facility in Waterloo, Ontario. It's been running for about 6 years now. So it's actually co-located on a rubber compounding company's campus. So Airboss Rubber Solutions was actually our very first customer. So they use our product in a bunch of tire applications. The main product they've been using it in is an OTR retread. So they've been using it, our tire-derived polymer, in an OTR retread product at the 20% level. So they use 20% of our recycled material, and they use 80% of their regular material. And they've been doing that for about 6 years now. In fact, just last year, we passed a pretty significant milestone. We've retreaded over 10,000 of these large tires with 20% of our recycled material. Now, Cal Tire, who I think they are present at this conference in some way, I don't think they have a booth, but they are one of our largest customers and one of our biggest partners here. And so Cal Tire does a lot of retreading on mining services and truck tires as well. And so we continue to have a great relationship with them, and hopefully this is really just the start of what's possible. Now, a lot of manufacturers, and Ewan was pointing at this earlier, a lot of manufacturers are talking about sustainability and talking about being more sustainable, using more recycled product. But what does that really mean? What does that really mean, and what are the tire manufacturers saying? And again, as Ewan was mentioning, I think there's just a little bit of discrepancy between what people are saying and what people are acting on. But you can see whether it's Continental, Bridgestone, some of the largest in the world, or even Nokian and Apollo, which are a little bit smaller manufacturers, they still basically all have the same kind of, these quotes came straight from their sustainability reports. So you can see Continental says, to avoid waste at the end of the product's service life, the circular economy will be the economic model of the future. And so that is really what Tyromer is trying to do. We're promoting tire-to-tire recycling. We want an old tire to be in some way be able to be used in a new tire. Now, Bridgestone says, they want to work to decrease the amount of natural resources required for products. Well, great. We have 1.5 billion waste tires that are going to come every single year. Let's use those. And so we can really see that, again, companies are aiming to reduce their emissions and really looking lately to secure raw materials. That's a really big thing that's just become more important even this year. And so I want to talk a little bit more on a larger scale about how does devulcanization fit in the tire and rubber industry. And actually, this isn't just devulcanization. This also applies to something like Pyrum, where it's recycled material. So how does recycled material fitting in the tire and rubber industry. There's 4 major areas. So obviously sustainability, that's why we're here to talk about. Producer responsibility is something very big I'd like to touch on as well. It really promotes a circular economy. And again, something very important lately is a distributed supply chain. And so in sustainability, we consider, Tyromer considers devulcanization as the best practice because we can return old tire rubber into new tires. And so we feel that that is the simplest link of tire-to-tire recycling. We can take old tires and use a portion of them to make new tires. Now, it's really a renewable resource, and this is something that I think is really important to understand. Again, this is something that's going to come each and every year. Whether you're in Germany or the Netherlands or Canada or Asia, there's going to be scrap tires that are produced every single year. And again, the TDP doesn't change the composition of the material, so it's going to have synthetic rubber, natural rubber, carbon black, etc. Now, producer responsibility is something that's becoming really important, mostly because of legislation. The governments are starting to require it. In places like Chile, parts of the United States, they've already mandated producer responsibility and extended producer responsibility, whereby the tire manufacturers have to help deal with the products at the end of their life. So that's a challenge for tire manufacturers today, is they're going to have to be dealing with more and more their own products at the end of the life. So they can't just think about the manufacturing and the sale of their products. They're going to have to think about how to use the material afterwards. And so right now, in terms of recycling, the EU actually does a really good job of this. You know, they collect and utilize 95% of scrap tires. However, as you can see in this image here, almost half of that is still going to energy recovery, so basically a cement kiln and burning. And so we think there's definitely better uses for that material. Right now, some of it is being recycled. We have crumb rubber, we have micronized powder like Iwan was mentioning, we have reclaimed rubber. But still, there's a lot of opportunity in the reuse stage. And so this is what EPR looks like today. And this is really what we see it transforming into tomorrow and in the coming years, is we're going to get away from this energy recovery and burning. There's much better applications than just burning. We've seen whether it's devulcanization, whether it's pyrolysis, whether it's micronizing, there's a better use for the material than simply burning it for the fuel value. So we're going to see more recycling, and we will continue to see more reuse. Now, I think this is something that we will see legislative action on soon as well. There's going to be mandates to use recycled material in tires coming, and I'll speak on a little bit more about that in a few more slides. So right now, you know, there's a little bit of a circular economy that's been developing in tires and tire recycling, but we're just starting to fill that gap in. So historically, we've kind of gone in a take, make, use, and dispose model. It's a linear model. It's a linear economy, basically. And now recently, with the development of recycling technologies, we can really add this recycling loop here, and we can take less, we can use less, and we can dispose less. So again, in a circular economy model, we are taking less from the environment. Now, something I'm sure everybody is aware of lately, the supply chain has been has had all sorts of disruptions lately from the last couple of years. Shipping has become incredibly expensive. And so how does recycled material fit into this distributed supply chain, and how does it help? Well, we really think the best practice is to buy local. So as our facilities, our licensed facilities, we want to be close to the manufacturers and where they need to be. So if a manufacturer needs a facility in India, we want to make that facility very close to them. We've actually just started our new facility in Arnhem in the Netherlands to help with the European market. We have 2 facilities in Canada to help with the North American market. And so we're really looking to reduce the distance of shipping, not just for CO2, but just in terms of material security. We can really insulate from supply shortages. We can have faster response time. We can, to an extent, protect from price volatility because, again, we know that this crop of end-of-life tires is going to come every single year. Now, this is something I don't mean to instigate pain with anyone, but a couple of years ago, it was maybe $2,000 to ship a container, and we might be looking at $10,000 or $14,000 to ship that very same container today. So in terms of manufacturers, a lot of prices have been increasing. This is a giant portion of it. So again, we really see that we have to focus on our best practice, which is to buy local. And then, of course, with the war, there's also been quite a big problem with materials coming from Russia, whether that's synthetic rubber, carbon black. And back in September 2020, the EU actually listed natural rubber as a critical raw material. And we've seen that actually since about September of last year, we've seen the natural rubber prices increase about 40%. So in less than a year, the prices has increased over 40%, and it's really put a strain on a lot of manufacturers today. So what is the future of tire recycling going to look like? Whether this is 20 years in the future, 10 years, I'm not really sure. So I'm really talking about what is going to happen in the immediate future. What is happening right now, and what is going to happen in the next few years? What is everybody in the industry going to notice in the next couple of years happening? So obviously, we've got to focus on material reuse. That's very important. And we've just got technologies now that are able to do this on a large scale. We're going to see a more organized recycling chain, where it's important that tires are sorted before they're shredded or cleaned before they're shredded. There's going to be different recyclers working together as there's different steps in the process. We're going to see an increased urgency and collaboration. We've heard talk about that, but now we're actually starting to see a lot of the manufacturers, they're starting to dip their toes in it and to take this more seriously and to put real projects behind it. And then for us, a focus on quality systems. Again, in order for us to be used as a raw material in the tire industry, they use an incredibly large amount of material, so we have to make sure that we're providing a consistent product so their products can stay consistent as well. So in terms of material reuse, traditional recycled materials like chrome and reclaim rubbers, they're often used as fillers. The difference with devulcanized material, it really is a functional material. So it can actually improve certain properties when you add it. So for example, when we add this into an OTR tire or a retread, we might see a little bit better tear strength, abrasion, or heat buildup. And so it is a functional material. It does take time to test. It's not something typically that you would just drop into a recipe and it works really well. It's like any other new raw material. You would want to develop it. You would want to do a testing and optimization to find the best uses for the material. And right now we're working with the majority of the top tire companies in the world in some states of testing. Some people are already making tires. Some people are just testing in the lab. But this is something that's really coming, and people are really starting to put the devulcanized material into more applications and more products. Now, something I said earlier, I think the legislation for including recycled rubber in tires is coming to the EU relatively soon. There's an example I like to give about the United States. So it was back in 2007 or 2005, something like that. It was the state of Minnesota. So a single state in the United States decided to mandate ethanol in the fuel. And so they mandated 5% ethanol in all the fuel. Now, all the car manufacturers in Detroit, the GM and Ford, they all said it can't be done. It's going to ruin our cars. It can't catch on. And today, 10% of ethanol is mandated in the entire United States, with a lot of them moving to 15%. So legislation, it takes one state to turn, but we really see that this is the movement. This is the way that things are going to be going for the future. Now I talk about a more organized recycling chain, and I think this is something that's really important. At least for us, for Tyromer, this is extremely important. The impact of sorting and separating tires is very clear. Now, our technology might not be the best solution for every single type of tire out there, but I can definitely say we're a great solution for all the truck tires, OTR tires, mining tires, the larger, the better in some sense for us. And so in order for us to create this consistent product, again, we have to have a consistent feedstock. That's why sorting and cleaning is really important. We don't want a product that has a lot of dirt and fiber and metal in it, because we can't pass that on to a tire manufacturer. They won't accept it. So we really want to have control of the feedstock. We do that, again, through sorting and organizing. More care and more quality on our side on the front end means better potential usage for the tire manufacturers. And so really, again, that has been the huge thing with tire manufacturers. They really want to see a consistent product on a large scale. And we're finally to the point where we can provide that. Now, we're going to see more recyclers working together. Of course, we hope to one day bring the whole process inside our own, like Pyrome's. They're actually doing the shredding themselves in their own facility. That's great. Right now, we work with other recyclers to provide the solution for us. So we work very carefully with retreaders, with recyclers, with tire grinders, to make sure that we have feedstock that will be suitable for our products. But at the end of the day, it is still tire manufacturers who are the drivers behind the wheel. So, definitely we challenge them to not just test, but to really act on this, because we know the material can be used and has a lot of good uses for it. Now, we do think that we will see an increased urgency in collaboration. We're already starting to see it. In fact, I was at this conference 4 years ago, and we had just started the recycling hall, and there was just some talk about sustainability. But now, if you walk around, a lot of these companies, that's maybe one of the main messages that they're saying. They're talking about sustainability, environmentally friendliness, and finding ways to reduce their carbon footprints. Now, we're going to see this in terms of collaboration. We want to work together with these companies so we can find more uses for the product. Right? We've seen it used in truck tires. We've seen it used in large tires. But there's a lot of different tires out there. And further, not just the tire industry, but conveyor belts, general molded goods, things like that. For example, if you're making a shoe sole out of our devulcanized rubber, you can probably use 80% or 100% even in some cases. So it really just depends on the product quality that you need, and really the safety requirement, I think, is a big one. Now, for us, collaboration has always led to reduced project times and increased efficiencies. So if we can collaborate and we have great communication, to get a new material into the tire industry might take 3 years or 4 years. If we work closely together and we use our resources wisely and efficiently, maybe we can take that down to 1 year or a year and a half. So that's really what the collaboration is trying to do. It helps us with. And lastly, a focus on quality systems. Again, I've kind of been touching on this quite a bit already, but it really is the utmost importance. This is the biggest thing that tire manufacturers have a reason to say no. It's not consistent, it's not quality. But we've shown that we can do that. We have a very robust quality management system. We have our ISO certifications in all our facilities. We really do have a strong control. And just like any other manufacturer, so a tire manufacturer, when they get a new product, whether it's a natural rubber or whether it's a devulcanized rubber, there's a specification that product needs to make. If it doesn't meet the specification, then the tire manufacturer rejects the product. We are the exact same way in the sense that the feedstock, so the ground tires, that's our feedstock and that's our raw material. So we ourselves set specifications with our partners and with our suppliers to say, hey, if this material doesn't meet our specifications when we receive the material, then we just won't use it. It's that simple. And so that is how we control the quality and the consistency of our product here. So I just want to give a little bit of update about some of our facilities to show, again, that this is actually happening now. So we just had 2 facilities open late last year. One is in Windsor, Ontario, Canada. It's a larger facility with a production capacity of about 8,000 metric tons per year. We have a full lab there. We have this, so what's called straining is becoming very important in the recycled rubber industry. So straining is basically you're pushing hot rubber through a very fine mesh screen. So basically you're removing any contamination out of it. It's basically an extra safety step. So what we do, we devulcanize the rubber, crumb rubber goes into the extruder and comes out, and then we actually force this hot rubber through a fine mesh screen to remove any potential contamination. And that's just a quality check and something that gives the tire manufacturers and rubber manufacturers a lot of confidence in the material. Now this is our new facility in Arnhem, the Netherlands. I will show a little bit more about this facility because it's a little more relevant to the European market, of course. And it again has just opened late last year. So this is located in Arnhem and in the Netherlands. We took the train there from just the other day. And we really consider this like our production facility 2.0. So this has a little bit smaller production capacity than Windsor because it's meant to be a showcase for the European market. So there's a little bit less production capacity, but that is starting to build. Again, we have our full ISO certification already. We've passed the quality steps for a couple of large manufacturers. We do have full straining and again a full lab as well. So in this facility, we have two extruders. We have a 90mm extruder for standard TDP production. We have a 60mm extruder, which is a little better for synthetics and non-tire rubbers like EPDM. This is the straining here. So again, the hot rubber is getting forced through this mesh screen, and it removes any potential contamination. Now, it's much better for us to filter out the material first, so to work with the suppliers and the feedstock suppliers to make sure there's not a lot of dirt and metal contamination in this to start. But this is kind of like one of our last defenses. So as soon as we produce the product, it's still hot, it goes through this fine mesh screen, and then it goes downstream to packaging. Now this is, we have a little automatic stacking and metal detection. The metal detection is the very final safety step that we have. So as soon as the material is produced, it gets forced through the fine mesh screen and straining, and then it runs through a final metal detector before being stacked. Now we have a full QA and QC lab there. Everything that we produce comes with a certificate of analysis. And so again, we work very closely with the tire manufacturers to set a specification together. And so again, just to wrap up, this is what we see as the future of tire recycling. Again, we're really going to see a lot of focus on material reuse. We are going to see a more organized recycling chain. There's a lot more urgency and collaboration right now. And the quality systems, of course, is incredibly important to build that trust with the manufacturers. Thank you. Thank you, Iwan.
Thank you very much for that, John.
Thank you. May I take a seat?
Yeah, sure. Oh, it's great to see yet another project going from pilot to commercial. Now, I think we're going to have a Q&A session with Sasha. Yeah.
Yes. So, first of all, thank you very much, John, Pascal, and Yoon. You're the first speakers who have fully exploited your authority to speak this afternoon. So congratulations. But we still have a few minutes left for our Q&A session. If you have any questions, feel free. Just go ahead while we still have our speakers here on our tire stage. There we go. Just a second, you get your microphone so everybody can hear your question.
Okay, I was just wondering, is there a competition between the two processes you have? How do they compare?
That's a good question. So we actually get that a lot, and I think I'll answer this first and then go ahead after. But we really see the tire recycling problem is so large that no one company will be able to dominate. There's not one solution that's going to fit the entire industry. We have to have separate solutions because of the enormity of the problem. Again, we were talking about Systren putting up 20 facilities, and Tyromer is the same way. And still, if we both had 100 facilities running, I don't think we'd even come close to hitting the global requirement. And so the industry is so large that, yes, there is a little competition naturally, but at the end of the day, there's enough bread out there for everyone, I think.
I would say this. Can you hear me?
Yeah.
I would say it is insane to think that one company alone can solve the problem. Therefore, it's too much. That's what we see every day. And even what just BASF is expecting from us, the 100K tons per year, that's giant for a company like us. And for BASF, it's just a little drop in the ocean of what they need on a daily basis. So, yeah, there will be more competition, and competition is good for all markets.
Any other questions? Yes, here.
Yeah, hi, my name is Thilo from the company Alfa Laval. I was wondering, because you both have this process where you have one component and you split it into 3, 4, 5 different ones, like Pyrum, you had the Pyrum oil and you had gas, and I suppose in the Pyrum oil you have some solids and water also, and before it goes to, I think, BASF. And in your case, you showed this video where different fluids then came out of it. Was that correct, or was it all solids?
The water you saw was just for the cooling purpose, so it's really just the devulcanized rubber that comes out.
Okay, so my question to the both of you is, what kind of separation technology do you actually use to separate those different solids, fluids, and so on?
Do you want to start?
So, yeah. In fact, that is happening in our reactor. In fact, the rubber chunks after the shredding is separating rubber, steel, and textile fibers. So that's purely mechanical. It's just shredding, a lot of force and magnets and cyclones to take out the fibers. Then the fibers and the steel is sold at that moment already, and the rubber goes then into the reactor, and the reactor is heating the rubber chunks to, in our case, 700 degrees. Under pressure, and for about 40 minutes. And during that time, the only thing that remains left in the reactor is carbon. Carbon and metal residues that cannot evaporate at 700 degrees. And that's in fact the basis for the solid that comes out, which is then milled and pelletized. And everything that becomes vapor at 700 degrees goes out of the reactor, and that vapor goes then in fact in the simple refining process. It's distillated in 3 steps, so cool down, liquids are produced, and at the end, the last step is minus 10 degrees, and the gas phase that is still gas at minus 10, that is what goes into the power generators.
And this, sorry, the Pyrum oil, thanks first, but the Pyrum oil then has its different fractions of light oil and heavy oil and water inside, or?
We thought that makes sense to separate in several fractions, but in fact, if you sell it to the chemical industry that is using it as naphtha in the steam cracker, that is the basis for all chemical products they do. They don't need separate fractions. They need, like my colleague said several times, they need consistency. So as long as the oil remains always the same, they can use it. And we don't really need to do a lot of changings on the oil. And funny thing that we found out over the last years, that it doesn't matter what the tire looks like, if it's truck, car, bicycle, or whatever, the oil is always good for the chemical industry. We always inspect what they are looking for.
And for our process, we actually use the same starting process as Pyrum. So the shredding of tires is the first step in our process, but after we devulcanize the material, there's really no more separating of the product. From there, it's just basically what form does the customer want it in. Do they want it in a rope? Do they want it in a sheet? And so from the time that the product is devulcanized out of our extruder, it doesn't really go through any separation from there. Thank you.
Okay, thank you very much. Any other questions? If not, we have a perfect timing. Wow, 3 p.m.
Wow.
Just as we planned. So again, thank you very much for this second panel here in our Tire Recycling Forum. Thank you very much, Yoon, Pascal, and John.